Yeah, the second part, the second talk on the same topic. Just like Sebastian, I want to talk to you about how great open source is. And a small personal story, me and Sebastian, we actually did our PhD together. So we sat in the same office for like 4.5 years, every day, and he actually got me into open source. So it was good to hear him motivating talk. Okay, so the question is, why should you open source? And I think Sebastian has done a great job in already motivating this for you. I want to still say that kind of my view is, if we look at the current research landscape, there's actually 3 different types of papers, if you ask me, when we talk about reproducibility. And the first type, I would say, are zero reproducibility papers. These papers, and I think you probably have seen them, they present some very nice numbers, right? And they have like a nice idea, but there's just no code release attached to these papers. And so this obviously is a big problem for science, right? Because it means that if you want to build on this paper, you actually have to re-implement their approach. So you're kind of spending a lot of time to do it. And just judging by experience, if you actually sit down and re-implement somebody else's approach, very often you will not get the same numbers, right? And often, the numbers are actually much worse than they are actually published. Right? So this is a big problem for science, because then you have numbers, there's data out there in the paper reported that you should compare against, but you simply cannot reproduce them. So that's paper type number 1. Paper type number 2 for me is fake reproducibility papers. So these are becoming very common. So what you have here now is, again, of course, you present some favorable numbers, because that's what you do, right? It's a paper. You have to be successful, right, in your research. You put in a link to your code and say, oh yeah, it's here, open source, you can just look at it, but the code is actually terrible. And you probably have encountered this as well in your research. When you look at somebody else's code, you try to reproduce the numbers or even get the code to run from somebody else, and you find that you can't. So this code is borderline impossible to get running, or there is a script that actually does run, but it can be modified in a meaningful way. Right? And so you, again, lose a ton of time, and it's underline this. You lose lots of time trying to get this code to run, and also you cannot actually use this code to try out different alternatives. Right? Very often, a paper has kind of like a main idea and different applications, right? Different parts of the solution that maybe you want to switch out and try out something else. And with this terrible code, it's typically not possible to do it. And so very often, at least that we're seeing in my group, is that people say, they come to me, my PhD students, and they say, okay, I tried now for 3 days to get this code to run, it's not running, so I will just re-implement it myself, right? And so we're back at type 1 with all the disadvantages that you have a paper out there, and the numbers cannot be reproduced. That brings me to the third type of paper. Those are true reproducibility papers. They, of course, always have terrible numbers, right? But they're also well structured and well engineered, and the code is sufficiently maintained online that you can actually just download it, run it, and you can run regression experiments. Right? So you can rerun all the experiments, and if you say, hey, I like this part of the solution, but maybe if I exchange this part with something else, maybe the approach gets even better. Right? That's innovation. And really good code allows you to do this. It's well structured in such a way. And that means other researchers can extend this code for their own research and integrate it into their own research. And this is actually what we think is great for science, because this is how we all progress. Now, there's kind of a disadvantage, and I want to talk about this, because you have to, as PhD students, you kind of have to optimize yourselves, right? And while, of course, of the 3 different types of papers, basically 2 of them are useless for science, right? Only true reproducibility papers are actually good for science. We have to be honest that engineering something well takes a lot of time and effort, right? So if you look at just at the effort that is required, zero and fake reproducibility require almost none effort, right? Whereas engineering something in a nice way will cost you a lot of effort. And so the question that you have to ask yourselves as PhD students is, if it is so much effort to build something nicely, that's all this time that you're spending not writing papers, and if your only goal is to have many papers, is it actually worth it to do it, right? And so the question then becomes, is open sourcing worth it for science? Yes, but is it also worth it for you, right? And I want to give you some reasons why it's actually really good for you. So Me personally and Bastian have helped a lot, right? But why this actually really good? And the first reason is really uptake and visibility. Because at some point, people are not just going to look at you and ask how many publications do you have, right? That when you begin your thesis, that's what you're maybe focused on. I want to have 10 papers or something like this, right? At some point, people don't really care that much if you have how long your paper list is. At some point, people are going to ask how many people are actually citing you, how many people are using your work and building on top of your work, right? So what is your actual impact beyond the number of papers that you have, right? And so for this, open source is of course great, also for your visibility, because having a well-known repository that other people use really boosts your visibility as a researcher, right? So this is, just in terms of uptake and visibility, having research that people can reproduce is great for you. The other one, I think that's also a great benefit, is collaborative science. So it's my personal experience, so when I open sourced my big framework, users came in and they started bringing a lot of feedback, right? So they use your code, they suggest ways to improve your code or your methods, right? They find bugs in the code. And one very embarrassing bug I had in the very beginning, but people found it and we resolved it, right? So it's all good, right? And all of this actually will lead to partnerships and collaborations. So my chair currently collaborates with many different partners, many in industry actually, and just a big draw for industry is that we have these open source frameworks and people want to collaborate with us on these things. And now reason number 3 that is also super important for PhD students, I would say, or for any researcher, is that it gives you an additional channel, right? So paper review is unfortunately not always optimal, right? It can happen that good papers will get rejected. Your good papers might get rejected simply because you have bad luck with reviewers, people didn't understand what you were doing, and so this will unfortunately happen. And I see it in my group also. Some people have less luck than others. Sometimes a good paper will get rejected multiple times in a row. So all of this can happen. And one possible solution, or at least a different channel that you have, and this is what Sebastian was saying, put your paper immediately on archive. As soon as it's done, upload it, just take your claim, right? And advertise your method. Put out a library or some code, advertise it on whatever channels that you have, so that people can start using your work, right? And in fact, there's stories, I should have put some slides here for this, but there's a lot of papers that were only on archive actually first before they got published that had huge impact, right? If we look at the Bird paper, in my community in OP, Bird was a huge paper that was on archive for like a year. There were thousands of citations before they said, oh yeah, okay, let's also submit it to conference, get a best paper award, we got it right. But you know, so there's a different channel that can give you a lot of impact and visibility, where you kind of sidestep kind of the, not always optimal paper review process, right? So in conclusion, well-engineered open source research will cost you a lot of effort, but it's worth it, I would say. And if you're interested, you can check out some of the open source frameworks that we're developing in my chair. I would like to highlight Fundus, which is our library that allows you to crawl online news in a lot of different languages. A lot of newspapers are supported. It's 2 lines of code, you can build a big database. We have Flare, that's our NLP library, and we are developing lots of large language models that you can check out. So a full list you can check out on my page. And with this, I want to welcome you to the summer school and ask you to enjoy the next 2 days.